So what I'd like to talk about now is I'd like to talk about inverse functions. Um, what an inverse function is basically is this it's this idea that what we're going to do is if one function, if f, right, takes us from one domain to another domain to a range, f inverse is going to take us from the range where this thing, whatever this was before, to the domain, right? Basically, they switch places, okay? And so it's like a backwards and forwards, a back and forth. In order for a function to have an inverse, the function has to be one to one, okay? And what that means is that basically we can't have two values, right? Two values, like say for example 2 and 4, both going to say for example 16. From a function standpoint, that's fine, right? But the problem is that when we get the inverse, so this would be f, the inverse would have 16 going to 2 and 4, right? And that doesn't work, right? That's a no-go. We can't do that. So we are going to have to be really careful with the domain. Be careful with domains. So that's something that I am going to emphasize as I talk about this, okay? So let's actually give an example of something that might look like this. So let's say f of x is equal to x minus 7 squared, and we find a domain on which f is 1 to 1 and non-decreasing. Okay, great. So we've got this idea of 1 to 1, and then we need the non-decreasing. Well, here's the reason why we need that 1 to 1. So x minus 7 squared, okay, if I put in, let's say for example, I let x equal 0, okay, then um, we have f of 0 will equal 0 minus 7 squared, which is going to end up giving me 49. Okay? Or if f of 14, that's going to be 14 minus 7 squared. Okay? And that's also going to equal 49. You can kind of, if you need to pause, you can pause and actually just go in and check that that's going to be the case in terms of our functions. So this is a problem. Hence, we need to find an interval on which f is 1 to 1 and non-decreasing. Because the moment it starts to decrease, right, we're going to actually go back over our old values, right? We need it to be only increasing. That way we know that we're never going to end up having two x's go to, or two x's go to only one y, okay? And if you need to, you're going to have to go back and take a look at the book as they discuss that a little bit more. This is more of a review video, okay? Well, where is that? Where would that be? Well, I'm going to show you the graph. The graph of f of x equals x minus 7 squared. Okay. Two, three, four, five, six, seven is a parabola, upward facing parabola, that has its vertex at 7, 0. Okay, so it looks like that. Okay, so where does it non-decreasing? Well, it's going to be non-decreasing over here. That means like basically where it's increasing. And so you can start right here at x equals 7. So our interval is going to start at 7 and it's going to go to infinity. And if we do that, what we're going to end up with is we're going to end up with a non-decreasing interval. All right. The basic way to think about this is where the vertex lies will define a non-decreasing, or if it's upside down, it'll be non-increasing, non-decreasing interval. So basically, you're just looking, and it's going to end up being it's like this, not -7, but 7, right? Okay. So consequently, what we're going to do is we're going to take f, and how we write it is we're going to restrict it from 7 to infinity. Okay, and then it's gonna go to 0 to infinity, right? So its domain is going to go from just 7 to infinity. It's going to be all those values there, and then its range is going to be from 0 to infinity. And the good news here is that we can actually find a one-to-one function this way. Okay, if we restrict to that domain. Now, what that means, if you notice here, right? 0 is on one side of that divide, right? This value of 0, it's the f of 0, and then 14 was on the other side. So consequently, what you can see is we no longer have that problem, at least with 0 and 14. And if you see the graph, that basically eliminates all that problem altogether. Okay? So there we are. That's the restriction on the domain. So our domain is 7 to infinity. Okay? Now, to find the inverse, we'll take f of x, we'll set that equal to y, and that's going to equal x minus 7 squared. To find the inverse, basically what we're going to do is we're going to switch x and y, because y represents our range and x represents our domain. By switching them, we switch our domain and range, just like I talked about before. So that's going to go to x equals y minus 7 squared, and then we just need to solve for y. So this gives me, right, x, square root of x, okay, is going to equal, now normally it would be the plus or minus, but because we have restricted this to the domain, it's going to end up only being the plus side. So we only need to deal with the positive side, plus square root of x is going to equal y minus 7, and that means that y will equal the square root of x plus 7. Good news, yay. Okay, remember, by restricting the domain, it actually allows us to have the inverse. If we don't restrict to the domain, we are not going to be able to get that inverse. That inverse actually does not exist. Okay, and because we restricted it to only the positive side, this side over here, right? Only the positive side, that's why we're using the positive square root of x. Okay, now let's prove f inverse that we got here, okay, this one right here, this is equal to f inverse of x, is the inverse of f. Now, by definition, f inverse of f of x should equal x if the two are inverses. So let's do that. We'll use some composition. So remember, f inverse of x is equal to the square root of x plus 7. And f of x is equal to x minus 7 squared. Okay, so let's take f inverse of f of x. All right, so that's going to give me square root, let's write this out, f inverse of f of x equals the square root of x minus 7 squared plus 7. This is thus equal to, well, square roots cancel. That's going to give me x minus 7 plus 7. And again, we actually don't need to worry about the plus or minus because we've only taken one side. Okay, so this then equals x. Awesome. We can also take f of f inverse of x, and that should also equal x. So we're going to try that. We'll take f inverse, f of f inverse. Okay, so that means we have the square root. The square root of x plus 7 plus, or x plus 7 minus 7 squared, which equals the square root of x squared, which just equals x, right? So f and f inverse are inverses. That's how we prove that these two are actually inverses. All right? So there we are. In order to create our constructed inverse, you first have to restrict the domain to make sure that it is non-decreasing, okay, that it is never goes downward, okay, non-decreasing, and make sure that it's 1 to 1, and then all you need to do is switch x and y and solve for y. Let's try it one more time, and let's talk a little bit about this from a little bit different perspective. Excuse me. Let's try one that maybe is a little bit trickier algebraically. So let's take, for example, let's find the inverse for f of x equal to 11 over x plus 11. Okay, well, we're going to say, okay, we'll let y equal 11 over x plus 11. And what I need to do is I need to restrict my domain. So I know that x cannot equal negative 11, and I also know that y cannot equal 0. Okay, and if you ask yourself why, okay, it's because there's no way to get 0 out of 11 over x plus 11, right? The top is never 0, the bottom will never be 0, so consequently y cannot equal 0. All right, so we know that those two things are the case. Kind of got to keep that in mind. So now what I'm going to do is I'm going to switch x and y. So x is going to equal 11 over y plus 11. Okay, that's going to give me then x times y plus 11 is equal to 11. Now algebraically, that's then going to be xy plus 11x equals 11. And there's a reason why I did this, and I'm going to show you why right now. What we're going to eventually need to do is we're going to need to divide out the y. Okay, so we need to actually be able to isolate our x's. So now that's going to give me xy equals 11 minus 11x. That's my next one. And so hence y is just going to equal 11 minus 11x over x. And there it is. There's our inverse. Let's check and make sure it's an inverse. So we'll take 11, right? Let's find f of f inverse of x is going to equal 11 over 11 minus 11x over x plus 11. Oh, that looks tricky, doesn't it? Okay, so that's going to be 11, and then we're going to have to find a common denominator. Well, x is the common denominator for that bottom part. So 11 minus 11x over x plus 11x over x. And that is just going to end up equaling, okay, 11 over x, which equals 11 times x over 11, which equals x. Oh, the things you can do with algebra that just don't seem to be useful. All right, but nonetheless, what we did get is we did get x back. Okay, now let's try f inverse of f of x. All right, so that's going to end up giving me 11 minus 11 times 11 over x plus 11 over, sorry, go back up. Over 11 over x plus 11. Oh, that's rough. Don't worry too much about this. The algebra is going to be much easier on your exam, I promise. Or at least we won't have this part of it. So that's going to be 11 minus, okay, 121 over x plus 11 all over 11 over x plus 11. So 11 times x plus 11 minus 121 over x plus 11. times x plus 11 all over 11, which equals, oh, this is just shocking, 11x plus 121 minus 121 all over x plus 11 times x plus 11 over 11, which equals, 121, which equals 11x over 11, which equals x. Okay. So I want you to, like, for the purposes of this exam, don't worry too much about the fact that I did just a bunch of rational equation algebra. That could get really hairy, okay? There's nothing like that on this particular one. If you had an issue with how I did that there, we could talk about it after your exam. For the purposes of your exam, though, what you really need to get is this whole idea of f inverse of f of x will give me back x, and f of f inverse of x will also give me x, right? And how do we find an inverse? We switch x and y, and we do the algebra to isolate y, okay? And that's how we work with inverses.